there on 48. Now, we're looking at strong and weak acids. And we're going to have a look at different aspects of them. The questions aren't so tough, but I'm actually going to go into some really deep detail, because as much as you guys are you're absolutely brilliant. So you're not going to get a lot of this even in the questions that I've written, but it's really interesting to know. All right. So there are 3 strong acids that you're going to either come across in tests or that you're going to look on YouTube videos and see things. You've got hydrochloric acid, HCl. I don't actually call it, so when I talk to myself when I'm solving a problem, I don't actually call it hydrochloric acid, I call it HCl. Sulfuric acid, H2SO4, nitric acid, HNO3. The reason being, you don't technically have to know these till you're year 12, but if you know these, oh my God, it makes GCSE chemistry so much easier. So I teach you all to memorize them. All right. So if you look at HCl, it actually breaks down into 2 ions, H plus ions and Cl minus ions. The H plus ions, and you'll see in all 3, there's a H, these are all H's, is what makes an acid an acid. It's a H plus ion. Now, this is a very strong acid, meaning if initially you have 10 atoms, 10 moles, 10 grams, doesn't matter how much, doesn't even matter about the units, what will happen is that when you dissolve it, all of the HCl will dissolve and form H plus ions and Cl minus ions. This is why it's a strong acid. All of the acid separates. The technical word is dissociate. I missed an S out on dissociate. Okay, so the one I want you to have a look at, which looks really weird, is weak acids, is ethanoic acid. It looks very strange, but I'm only bothered in this. This OH, this hydrogen, snaps off and forms a H plus ion. This is why this is ethanoic acid. This is vinegar. It's got a funny looking arrow. The reason being, not all of it breaks down. If you have 10 moles, 10 grams, 10 molecules, only a very, very tiny amount will break down and release the H plus ions. So if you look at it in a strong acid, you've got 10 moles of acid, of H plus ions, sorry. With a weak acid, as much as I started off with 10 moles, only a tiny little bit broke off to form H plus ions. Okay, now I'm going to use some technical words. A strong acid completely dissociates, completely breaks down into H plus ions. Look at all these H plus ions. A weak acid only partially dissociates. Look, some of them are still stuck together. All right, let's just do a crazy pink. I think crazy pink will stand out. Oh yeah, that's not crazy pink. That's crazy pink there. Even that doesn't stand out. Let's see if we can highlight it. So these 2 haven't separated. They haven't broken apart. So it partially breaks apart. It partially separates. It partially dissociates. Okay. When you react a metal with an acid, you get hydrogen gas. You get bubbles off. If you get a strong acid, you'll get lots of bubbles. If you use vinegar, a weak acid, no, not so many. If you react it with a carbonate, you get lots of carbon dioxide with a strong acid, so lots of bubbles. If you react it with a weak acid, not so many. What pH would 1 mole per dm cube in that solution, we've done solution, would an acid be? Now, acids are down here, pH 1. And if you look 5, 4, 6, 5, 4, 3, 2, 1, the acid's getting stronger. You've actually got pH 0, which is even stronger. So strong acids have a pH of about 1. All right, 1 mole per dm cube student actually has 0. It doesn't matter. Ethanoic acid is a weak acid, so it's round about 3 to 4. It's down here. Is ethanoic acid. So what happens with universal indicator? These are the colours of universal indicator. If you have a strong acid, it will be down here, it'll be red. If you have a weak acid, it will be here, it'll be orange. It'll be around about 3, 4. Now, key things to know. Acids release H plus ions. Bases, which we're going to have a look at very, very quickly, release OH minus ions. A strong acid releases all its H plus ions, e.g. HCl. A weak acid releases some of its H plus ions. ethanoic acid. We've just done that. A strong base releases all its OH minus ions. Now I can give you an example. Sodium, this is the symbol, hydroxide. A weak base releases some of its OH minus ions, e.g. ammonia, NH3. pH scale, 0, bonkers, very acidic, 14, very alkaline. The interesting thing is each step is a 10 times change. All right, so what that means is, let's have a look here. I'm just going to delete some stuff over here. What that means is, if I have an acid of pH 2 compared to an acid of pH 1, the pH 1 is 10 times stronger. So each whole number you go down, it is 10 times stronger. So when you look at something that is pH 4, people think, it's only 4 times stronger. No. Each step is 10 times stronger. So 10 times 10 is 100, times 10 is 1,000. So a pH 1 acid is 1,000 times stronger than pH 4. Right? This you will see in things like earthquakes on the Richter scale. Okie dokie. Neutralization. This is when you mix an acid with an alkali. A H plus ion will react with an OH minus ion and form water. Right? Strong acids and bases react completely. Weak acids only a little tiny bit. All right. 6 minutes. Oh, that's not bad actually. 10 easy, 10 medium, 10 hard. You know the score. Let's get thinking.